All right, so today let's talk about how to change a derivative statement into an integral statement. And this is basically a review of Calculus 1 and to remind ourselves what an antiderivative is. So number one, find out tangent x prime, and we will write down the antiderivative statement. Okay, so what's the derivative of tangent x? Do you remember? Anyone?
Secant x tangent.
No, close.
Secant x squared?
Secant squared, right. Secant x squared. So, although this is the meaning of it, rather than this, people just write down secant squared of x. So this is like the shorthand for this thing. Okay? All right. So once you know that if you differentiate tangent, you get secant squared, what is the corresponding integral statement? Integral of secant squared of x dx is tangent x. Is that it? Are we forgetting something?
Plus c.
Plus c. Don't forget the plus c. Okay. Now let's try something that's slightly tougher. Number two, try this thing. ln of tangent x plus secant x prime. Okay, so the first thing that you have to know is how to differentiate a log. What's the derivative of a log of x?
1 over x.
Good. And what's happening here is that this entire thing, tangent x plus secant x, is inside the log of x. And when you have a function inside another function, you're supposed to use? Yes? Chain rule. Good. So we're going to use the chain rule. And how do you apply the chain rule? Well, you just pretend that this is a single letter. Like if you go to Egyptian tombs, they're like long hieroglyphs. Right? Think about that as like one complicated letter. So rather than like this, think of this as like something like an X. Right? And of course, this is saying that the derivative is 1 over this complicated looking letter. But we don't stop there, do we? What do we do after this? Yeah, you have to, whatever you treat it as a single letter, you're supposed to differentiate. You have to differentiate this. All right, so let's try to simplify this. 1 over tangent of x plus secant of x. What's the derivative of tangent x again? Secant squared. And then what's the derivative of secant x? Yes?
Is it cosecant squared?
No, it's not. It's totally unrelated. That's totally
Secant
wrong.
x tan x.
That's the one. Yes, the one that you said. Secant x, tangent x. And I'm strongly against your answer that is it cosecant, because people do make a mistake thinking, oh, what is secant is like 1 over cosine, so maybe if you differentiate, cosine turns into sine. I mean, it's a good guess, but unfortunately it doesn't work that way. Yes?
So the derivative of secant x is secant x times tan x?
Yes, yes.
Okay.
This is the derivative of secant x times tangent x. Okay. Now, we've completed the derivative, and therefore we can write down that the integral of this is this other one. However, that's not what I want. I actually want to simplify this further. Okay. Do you see a way to simplify this one? Yes.
You can cancel out the secant x and the tan x, so we'll leave you secant squared x.
You're one step ahead of me. What I had in mind is just yes.
Take a secant out. Yeah.
Take the secant out. Yes, yes. So you want to do 1 over tangent x plus secant of x And then after taking it out, then we can do what you just said, okay? So once you factor out this, you yank the secant out from the first one and also the second one. So inside the parentheses, these two are left, right? And once you take that out, you see that secant x, tangent x, tangent x. So this here is exactly the same as this other one, which means you can cancel, right? So we cancel the 2. And the result is that, oh, it's a secant of x. Okay. Now, write the corresponding integral statement. What is it? Integral of secant x is equal to that thing that we differentiated, ln of tangent x plus secant x.
Plus C.
Plus c, thank you. Now, for the reason I haven't explained fully, in class, instead of a parenthesis, we will actually be using an absolute value. I'll explain shortly. Other than the absolute value, do you have any questions?